You know that feeling when you look up at the night sky? Just pure wonder. With our own eyes, we can see thousands of stars. But for most of human history, that's pretty much all we had. Then, an invention came along that gave us brand new eyes and turned those little pinpricks of light into entire worlds, sprawling galaxies, and, get this, even the echo of creation itself.
This, right here, is the story of the telescope. And it's so much more than just a tube with some glass in it. It's a time machine. It's a portal to places we can't imagine. It took stargazing from just a hobby and turned it into a full-blown science of discovery, completely rewriting our place in the universe, over and over again. So here's what we're going to cover. We'll start with those first spyglasses that changed everything. Then, we'll see how using mirrors let us build absolute giants to peer even deeper. We're going to break free of Earth's atmosphere for the clearest view possible, learn to see a totally invisible universe, and finally, look at the next giant leap in astronomy.
Our story kicks off in the Netherlands, back in the early 1600s. And funnily enough, it doesn't start with an astronomer, but with a guy who made eyeglasses.
So, in 1608, a fella named Hans Lippershey filed a patent for this thing, a simple tube with lenses. Now, he didn't actually get the patent. Turns out the idea was already kind of floating around. But he's the one who really kicked off the whole revolution. News of this spyglass spread like wildfire, and it didn't take long for it to get into the hands of someone who wasn't just interested in looking at distant ships, but at the heavens themselves. And that someone was, of course, Galileo Galilei. He took the design, made it way better, and pointed it up at the sky. And what he saw, it changed the world. The moon wasn't some perfect heavenly sphere, it had mountains and craters just like Earth. He saw that Jupiter had its own moon circling it, a mini solar system which proved not everything orbited us. These discoveries were the hard evidence that just shattered the old Earth-centered view of the universe. But Galileo's telescope had its problems. The lenses created this really frustrating color fringe, like a weird rainbow halo. Plus, you couldn't make them too big before they'd literally start to sag under their own weight. To see deeper, to see clearer, astronomy needed a whole new idea. And that breakthrough? Well, it came from none other than Isaac Newton.
Newton's idea back in 1668 was absolutely brilliant. Instead of a lens, why not use a curved mirror to gather the light? This reflecting telescope totally solved the color problem, but more importantly, it meant you could build them bigger, much, much bigger. A whole new race for cosmic clarity was on.
What's really wild when you look at this timeline is how fast things started moving. For a couple of centuries, progress was pretty steady, but then the 20th century hit and things just exploded. We went from small workshop mirrors to giants like the Hooker telescope in 1917. That's the one that proved those fuzzy patches in the sky were actually entire galaxies outside our own Milky Way. Then came Hale, then Keck, each one just blowing the doors off what we thought was possible.
But even with these incredible giants on the ground, we had a huge problem. You see, we're basically looking at the universe from the bottom of a shimmering ocean of air. Earth's atmosphere blurs everything. So the solution was as crazy as it was genius. What if we just put a telescope above all that air? And that's exactly what we did. In 1990, we launched the Hubble Space Telescope, and it gave us a view of the cosmos so clear, so sharp, it was just unimaginable from the ground. It was like finally wiping a dirty, foggy window clean and seeing the universe for the first time in all its stunning glory.
I mean, Hubble's legacy is just breathtaking. It wasn't just about taking pretty pictures. This was revolutionary science. It helped us nail down the age of the universe. It gave us the smoking gun for supermassive black holes. And it delivered one of the biggest shocks in modern science, the discovery that the expansion of the universe is speeding up, pushed along by some mysterious thing we now call dark energy. But here's the thing. Even Hubble can only see one tiny little slice of reality. Everything we've talked about so far, from Galileo to Hubble, was all about visible light, the stuff our eyes see. But the universe is humming with other kinds of light, and one of the most important is radio waves. And they have their own incredible stories to tell.
And the story of radio astronomy starts like so many great discoveries do, completely by accident. This guy Carl Yansky was an engineer trying to figure out what was causing static on transatlantic phone calls. He found this faint, constant hiss in his receiver that wasn't coming from anywhere on Earth. He figured out it was coming from the center of our own Milky Way galaxy. Just like that, a whole new window on the universe was thrown wide open.
This right here is the perfect example of why this is so cool. On the left, you've got the galaxy M87 in normal visible light. Looks like a big fuzzy ball of stars, right? But look at the picture on the right. That's M87 in radio waves, and suddenly you see this enormous jet of particles being blasted out from the supermassive black hole at its center. It reveals this incredible, violent, energetic stuff that's completely invisible to our eyes. Radio astronomy gave us a whole new cosmic zoo. We discovered things called pulsars, these spinning, dead stars that flash like lighthouses, and quasars, which are these incredibly bright galactic cores. But maybe most profound of all, it let us detect the faint afterglow of the Big Bang itself, the oldest light in the universe. So we can see invisible light, we can see in radio. Where do we go from here? Well, the next generation of telescopes is being designed to answer the biggest questions we have today. Get ready for what they call the extremely large telescopes, or, ELTs for short. And when they say extremely large, they are not kidding. We're talking about telescopes with mirrors that are 30, 40, even up to 100 meters across. These things will absolutely dwarf every telescope that's ever been built. It's a true quantum leap in our ability to see the universe. So why do we need to go this big? It really comes down to two simple things. First, a bigger mirror is like a bigger bucket for catching light, which means we can see things that are incredibly faint and far away. Second, it gives us insane resolution, the ability to see things in super sharp detail. A bigger eye sees both fainter and clearer, and that is the key to unlocking the universe's deepest secrets. And all that power is going to let us tackle what might just be the most profound question humanity has ever asked.
For the very first time, we're going to have telescopes powerful enough to take actual pictures of planets like Earth orbiting other stars. But it gets better. They'll be able to analyze the light that passes through those planets' atmospheres and look for the chemical signs of life, things like water, oxygen, methane. We are right on the verge of being able to answer that question, are we alone, with actual scientific data.
And beyond just the search for life, these ELTs will be our main tools for cracking the biggest mysteries in the cosmos. They'll help us map out the invisible scaffolding of dark matter that holds galaxies together, measure the dark energy that's pushing everything apart, and even see the light from the explosions of the very first stars. I mean, these are the biggest questions in science, and the ELTs are going to be on the front line. And this is why it's so critical. Just look at this chart. It's the cosmic budget. See that tiny little 4% sliver? That's everything we've ever seen. Every star, every planet, every galaxy, all of it. The other 96%? That's the great cosmic mystery of dark matter and dark energy. ELTs are being built to go explore that huge invisible frontier and finally give us a complete picture. So what a journey, right? From a simple lens that showed us we weren't the center of the universe, to giant mirrors that revealed billions of galaxies, to instruments that can see the invisible and will soon take pictures of other Earths. With every single leap in technology, our universe has just gotten bigger and weirder and way more wonderful. But here's the final thought I want to leave you with. We always build these amazing machines to answer the questions we have right now. But the real history of the telescope shows us that its greatest discoveries are always the things we never, ever expected to find. The next generation of telescopes will answer some of our biggest questions, for sure. But the most exciting part? Thinking about the new mysteries they're going to uncover, questions we can't even imagine asking today. What's next? That is the real adventure.